So I had a question from someone that wanted to know, can a ketone feed cancer? Okay, we know about glucose and glutamine, but what about ketones? Okay, so I basically contacted Professor Seyfried, Thomas Seyfried, and I asked him this question, and I'm going to be doing this video based on what he told me, which is some very interesting data. If you don't know anything about Professor Seyfried, he is the top expert on cancer. And if you haven't seen the video, I'll put the link down below where I interviewed him. This guy is super, super smart. He does research on cancer, and he knows probably more about ketones than anyone that I've ever met, especially in the research department, knows as much as he does about cancer and ketosis and fasting and the research on a low-carb diet and what it can do for your immune system and what it does for cancer. So I'm going to try to keep this very simple, but I want to explain what he said, and I want to also give you a link to the article that he posted about this topic. So the first thing he said was ketones and fatty acids might be used in some slow-growing tumor cells that have retained some level of respiratory capacity. Now I have to explain what the heck that means, starting with this right here, respiratory capacity. When you look at the difference between a cancer cell and a normal cell, there's one big difference, and it's how that cancer cell is using its fuel or metabolizing its fuel. And we're talking about inside the mitochondria. That's the energy factory in the cell. So the difference between a cancer cell and a normal cell. In a normal cell, you have this mechanism, this machine called the respiratory chain. There's other words for it too. And it's a series of biochemical reactions that basically take food or fuel with the help of oxygen and burn it for energy, and turns into the body's energy currency, which is ATP. Okay? So we're taking fuel and turning it into something the body can use to run all the different metabolic processes. So oxygen is the key thing right here. That's why it's called respiratory, as in breathing, right? So there's all these different biochemical reactions that occur in this thing called the Krebs cycle. When this system is damaged, okay, then there's no oxygen. Then how are the cells going to turn fuel into energy? Well, they have a plan B. They can convert over into a different mechanism where they ferment glucose and glutamine, which is a specific type of an amino acid. So cancer cells ferment glucose and glutamine, and normal cells go through the respiratory chain using oxygen. Okay? This system does not need oxygen. All right? That would be the difference. So ketones and fatty acids might be used in some, that's the key word there, slow-growing tumor cells that retain some level of respiratory capacity. So in other words, unless that cancer cell has retained some of this function, it potentially could use some ketones and fatty acids. Okay, so that's what that means. And he also mentioned this, from all of his research, without exception, all tumors show this pattern right here, damaged respiratory chain. So he goes on to say, fatty acids and ketones can support this plan B, okay? Hear me out, because this is going to be really important. Next point he talked about. Fatty acids cannot support in vitro, that means outside the body, tumor cell growth in the absence of glucose and glutamine. Talk about fermentation. So if you were to raise your carbohydrate level and provide glucose or even this glutamine, which is an amino acid, okay, and you also were burning ketones or taking ketones, that tumor cell or some tumor cells could potentially use ketones or fatty acids as part of the fuel. But if you keep this very, very low, okay, the cancer cells cannot support the tumor growth. I hope I explained that pretty simply. So it's a bit of a complex answer to a question. I put a link to his paper down below for you to dissect if you're really interested. It's fascinating. He'll explain this in much more detail there. Just make sure you have a medical dictionary to look up the words because there's quite a few. Thanks for watching.